All right, this is part 2 for Monday. I just got done recording part 1 for math, and I noticed that it's the longest video that I've ever done. I hope I don't have trouble uploading it. Anyway, let's jump right in. We're on page 405 now, and we're on problem number 15. So let's go ahead and solve this. We have 1.5 times 0.5. I'm sorry, I said 1.5. We have 0.5 times 0.5 plus 0.5 divided by 0.5. Just let me make sure I transferred all that information correctly. Yes, I did. All right, first things first, there's no parentheses, so we go to step number 2. We do multiplication and division first, from left to right. So I start here. 0.5 times 0.5 is 0.25. Now I go to my division operation. 0.5 divided by 0.5 is 1. And now I can add these together. 0.25 plus 1 is 1.25. So that's the final answer to problem number 15. And all this is exercising what we learned in part 1 of orders of operation and which operation to do first, second, third, fourth, and so on. All right. Next, number 17. Which digit is in the hundredths place in this number? Okay, so let me make my decimal a little bigger so you can see it. All right. We have here the 2 is in the ones place, the 1 is in the tens place, T-E-N-S, tens place. Next we have the 3 in the tenths place, that's T-E-N-T-H-S, tenths place. We have the 4 in the hundredths place, 5 in the thousands, 10,000s, and so on. Okay, but we found the one we're looking for. Okay, so tenths, hundredths, thousands, 10,000s, 100,000s, and so on. All right, but this is our culprit to be found. So 4 is in the hundredths place. It's important to be able to identify the hundredths place because we're going to be using that a lot, especially in the lesson number 84, when we're going to be converting fractions into decimals, percentages into fractions, and so on and so forth. So it's important to be able to identify the hundredths place value. We'll learn more about that in lesson 84. Problem number 19, okay? We're looking for the prime factorization of 700, but we want to represent the prime factorization in exponents, and I'll explain that in a minute. So I like doing the stacks, I don't like doing the trees. So I've got 700, I start off with 700. And then I need to divide it by the smallest prime number that goes into it evenly. Now the smallest prime number that goes into 700 evenly is 2. So 700 divided by 2 is 350. And now I repeat the process. Find the smallest prime number that 350 can be divided by. And I find that it's 2 again. So 350 divided by 2 is 175. And I repeat the process. Find the smallest prime number 175 can be divided by. It's 5. And then 35, again 5. Okay, 35 divided by 5 is 7. Same thing, I need to find the smallest prime number that 7 can be divided by. In this case, it's 7, because 7 is a prime number. Now, what does it mean by representing the prime factorization with exponents? We simply do this. 2 times 2 is going to be represented as 2 squared. 5 times 5 is going to be represented as 5 squared. And then 7, because it's not being multiplied by another number, is left alone. This could also be written this way. 2 times 2 times 5 times 5 times 7, okay? But when they ask you to write it with exponents, this is what they are looking for. All right, on to the next one. I mix these up, so let's go to problem number 21, then we'll go to problem number 23. The perimeter of a square is 1 meter. How many centimeters long is each side? Okay, so the entire, okay, the lengths have already been added, okay, and it's expressed in meters. So the perimeter of this square is 1 meter. Now we know there are 100 centimeters in a meter, okay? So the perimeter in centimeters would be 100. So to find how long each side is, all I did is divided 100 centimeters by 1, 2, 3, 4. 4 divided by 100 is 25. Our unit of measurement is centimeters, so your final answer is 25 centimeters. Number 23, I almost skipped it. Number 23, what time is 5 hours and 30 minutes after 9:30, okay? Some of you can do this all in your head really fast. Ever since I was little, I could not do it. I always got the wrong answer on these problems. So I'm gonna go ahead and show you how I did it, all right? We've got 9:30, from 9:30 to 12:30, there's 3 hours, okay? So that's 9:30 p.m., I probably should have written that down, and this is 12:30 a.m., 12:30 in the morning, okay? So that's 3 hours. From 12:30 to 2:30, there's 2 hours. So that gives us our 5 hours, okay? But we're told what time would it be? What time is 5 hours and 30 minutes after 9:30 p.m.? So we've got our 5 hours, now we add our 30 minutes, which takes us from 2:30 to 3. Okay, so your final answer should be 3 a.m. Now, let's go on to problem number 25. What are we on? Problem number 25. Problem number 27. I don't know where I hit it. Is this problem number 27? But I didn't write it. Yes, it is. Problem number 27. Sorry, I didn't write the number on there, so it threw me off. We've got 25 feet plus 24 inches, okay? But they've asked us to solve it in inches. I could either change 24 inches into feet and add that, but because the information is asking for inches, I'm going to change 2 feet into inches. So we know that there are 12 inches in a foot. If there's 2 feet, if it's a 2-foot measurement, we're going to multiply 12 times 2, which gives us 24 inches. So 2 feet or 2 foot equals 24 inches. So I add 24 inches plus 24 inches is 48. Now notice that I didn't square the inches, okay? Because it's the same unit of measurement. We're not multiplying. We write the square when we multiply 2 units of measurement together. So say I have 1 inch times 1 inch equals 1 inch squared. But 1 inch plus 1 inch would just equal inch. Okay, the unit of measure would just be in inches. Well, if this is a 1, it would be 2 inches, and so on. Okay, so it's the difference between multiplication and addition of units of measurement. Okay, our last one. This one's fun. All right, we're on page 406 now. We've got a triangle, has the vertices at the coordinates of 4 and 4, okay? X4, Y4, and X4, Y0, and at the origin. So we're gonna draw the triangle on the graph, okay? So remember, the origin is the center. It's where the x-axis and the y-axis intersect. So 0, 0, x0, y0, that's the origin. Okay, so that's one of the vertices. The other vertices of the triangle was set at x4, y4. Okay, so x is here, so 1, 2, 3, 4. That represents x4, and y4 is represented in 1, 2, 3, 4. So this point right here is labeled x4, y4. Your next vertices is set on x4 and y0, so that means it doesn't go up or down. Okay, so it's on the it remains on the x-axis. So I go then we're asked to form a triangle here. The first question, problem A, how many full squares are in the triangle? If you can't see this very closely, go ahead and draw this out on your graph paper if you have any. If not, just go ahead and use this on the board. I'll go ahead and count them off. How many whole squares are inside this triangle? So I count 1, 2, 3, 4, 5, 6. There are 6 full squares within this triangle, so the answer to letter A would be 6. And then the part B says how many half squares are in the triangles. So if you see here, my line to make this side of the triangle cuts through the squares to make and cuts them in half. So I'm going to count these half squares here. 1, 2, 3, 4. So I count 4 half squares. Now, if I would have drawn my line a little crooked, it would have been harder, but drew a pretty straight line there, which I'm pretty proud of myself that I did that on a chalkboard. Anyway, I think that's it. That is it for us today. I really hope you guys did well on these problems. I know it's double what you guys are used to doing over the last few weeks. But I hope you get it all done in time. And again, if you have any questions, just give me a call, shoot me a text, leave a comment on the video, and I'll get back to you as soon as possible, guys. All right, thank you. Bye.